conduction system of the heart. Okay, and this is basically how this electrical impulse is propagated through the heart, okay? So we'll start off with our heart. We know that we have our 4 chambers: right atrium, left atrium, right ventricle, left ventricle. And again, please go over this anatomy if you haven't done so already, or if you're not already familiar with it from prior knowledge, okay? Now, let's just put where our valves are. We know that valves are moving blood from atria to ventricle. These are called AV valves. And we also know the presence of our 2 cluster of pacemaker autorhythmic cells. So we have one cluster up here. This is called the SA node. Okay. And then we have another cluster down here, which is called the AV node. These are our 2 main pacemaker cells. We also have our conduction fibers, right? The bundle of His, which is in between both ventricles, the septum here. The bundle of His. Okay, I hope that's a little bit clearer. All right, so we have the SA node, the AV node, the bundle of His, and then we have our bundle branches. We have left or right bundle branches, and then we have left bundle branches, and then finally we have Purkinje fibers. And the Purkinje fibers are actually running through the ventricles and up towards the valve. Okay. So let's look at what's happening as the impulse moves through here. So the first thing is that the impulse is going to start at the SA node, and then it's going to rapidly move throughout both atria. Okay? It's going to start at the SA node, which is on the right, and then it's going to rapidly move throughout both atria. So the impulse propagates to both atria. And then both atria will contract. All right, now the impulse is going to arrive at the AV node, but it's going to do so after a brief period, right? This is called the AV nodal delay. So the impulse arrives, let's put it here, AV nodal delay. This is where the impulse arrives at the AV node. And that's going to be in between the atria and the ventricle. So it's going to get down here. Right? And again, this is really important. Both of the atria must contract before this impulse gets down into the ventricles. Okay, we don't want the atria to still be contracting as that impulse moves beyond the atria, beyond towards the ventricle. So both atria contract fully, then that impulse gets to the AV node, and this is called the AV nodal delay. Then the impulse goes from the AV node here out towards the bundle of His, right? So it's going to move towards the bundle of His. This is also called the AV bundle. And this is in between both atria, both ventricles. Okay, that's also important to understand. So when the impulse gets to the ventricle, it's not going through all of the ventricular wall, it's moving purely through the septum. So we're not having contraction of the ventricles just yet, but this is just a way for the impulse to get from the top chambers down to the bottom of the heart, okay? So the impulse comes down the middle of the septum, and then it moves up through the ventricles that way. So we go from the AV node down to the bundle of His, and then we go to the left and right bundle branches. So this impulse sort of splits off when it gets to the bottom of the heart, and then it begins to come up through both of the ventricles. Okay. So here the impulse divides into right and left bundle branches. Okay. So we're going to have this impulse being split off here. Some of these are going to travel via the left bundle branches up to the left ventricle. Some of this is going to travel via the right bundle branches up to the right ventricle. Okay. And then step 5 here, we have the impulse arriving at the Purkinje fibers, where the impulse now engulfs both ventricles. This is where we see ventricular contraction. Okay, so the impulse is really trying to make its way down to the bottom of the heart, and then it's going to squeeze the heart, almost the way you would squeeze a tube of toothpaste from the bottom up. You're going to get the ventricles contracting from the bottom up towards the valve. And that's really important because the blood is trying to leave this chamber and exit the heart through these valves. So we need it to contract from the bottom upwards to kind of squeeze that blood from the ventricle into the vessel. Okay, I hope that makes sense. Let's write this out first. So the impulse propagates through Purkinje fibers. This is on both sides, right? Purkinje fibers on both sides and towards valves. Okay, and then here we have both ventricles contracting. Okay, so the final part of this is where most students get confused, right? The impulse does not move from the AV node and then contract the ventricles. It must get to the bottom of the heart first, and then it's going to contract in that bottom to top mechanism, kind of the way you would, again, squeeze a tube of toothpaste to get the blood to move from the ventricle out into the vessel, into exiting the heart, right? Exiting the ventricular chambers. So let's just highlight this a little bit, just so that we can see the flow here. Right, so we started with the SA node. Then we move to the AV node. Then we go to the bundle of His. Then we go to our bundle branches, right and left. Then we go to our Purkinje fibers. Then the ventricles contract. So both atria contract fully, then both ventricles contract fully. Okay. Any questions on that? Any questions on this? Okay. So this is how the electrical impulse moves through the heart and generates a very timed, very rhythmic contraction of the heart chambers. Okay. All right. Okay, so let's go through the steps here again, just as a revision. So we mentioned that the impulse will start at the SA node. The SA node is at the top of the right atrium. It's going to propagate out to both atria, and it's going to fully allow both atria to contract. Okay. Then it's going to get to the AV node. Right after that AV nodal delay. And then how do we get that AV nodal delay? What would explain that AV nodal delay? Why doesn't the AV node just beat? It's also a pacemaker, Sal. Why doesn't it just spontaneously fire its action potential and contract? What is making sure that there's a delay there? I kind of touched on it earlier. What about the SA node and the AV node make sure or ensures that there's a delay in between the firing rate of these cells? It's the rate of action potentials, right? How many action potentials does the SA node fire? About 70 to 80, right? How many action potentials does the AV node fire? Around 60, right? So because the SA node is firing faster than the AV node, there's that inherent delay, okay? That is what is creating or sustaining the delay between these two groups of cells, okay? So then the impulse gets to the AV node, and then it moves down into the bundle of His, and then it goes to the right and left bundle branches here, which are splitting off down towards the septum here. This is the septum. And then it gets to the Purkinje fibers, and you can see the Purkinje fibers are actually running up into the ventricles and towards the valves, right? This is really important. Because they're running towards the valves, we're gonna squeeze blood from the bottom of the chamber up towards the valve so that the blood can leave this chamber and go through the valve and exit the heart.